Hello YouTube, welcome back to another lesson on biology and geology. Today we are going to review Unit 2. So let's go over this unit which is called the Geosphere, Minerals and Rocks. This is a long unit and probably I will split this video in two parts. So let's begin and let's see how long does it take. So what is the geosphere? The geosphere is the surface and interior of the earth made up by rocks, minerals and landforms, right? So this layer, the geosphere, it can be divided into three other systems or layers. Okay, these three layers are called the crust, which is the outer layer, la capa más exterior, the mantle, which is in the middle, and the core, which is the inner part. Okay, so now we are going to explain a little bit about all of these three layers. The crust is the outer layer and is the least dense, right? So these layers are in order of density from the less dense layer to the most dense layer, which is the core. During the classes at high school, I explained that the reason why we can see this difference is because when the Earth was formed, it was at the beginning like a big ball of melt rock. So when the Earth was cooling down, the less dense substances or minerals or elements went to the surface, and because of the gravity, the denser materials sink to the center of the earth, right? Because of the gravitational attraction. So that's the reason we have this geosphere divided in three layers from the least to the most dense layer. Por eso tenemos esta separación en tres capas, desde la más densa en la superficie hasta la más densa, que es el núcleo, en el interior, atraído por la fuerza de la gravedad. It's a similar process that if we mix water and oil, the oil tends to stay at the surface because oil is less dense than water. El aceite es menos denso que el agua y tiende a flotar sobre el líquido más denso, que tiende a estar en el fondo. Y algo parecido pues pasa con las capas de la Tierra. So the crust can be divided in two types of crust. We can distinguish between the continental crust and the oceanic crust. The continental crust is thicker than the oceanic crust, and the main component is granite. Granite is an igneous rock, we will see it, and is less dense than the oceanic crust. If it's less dense, that means that try to float on top of the oceanic crust. Okay, the oceanic crust is thinner and more flexible and is more dense, so it will try to tends to sink under the continental crust. And the main component of the oceanic crust is basalt, another igneous rock which is very dark, almost black, and is denser than granite. Usually, the continental crust is well known for all of us because continents where we live are included or are made by continental crust. So the mountains, the valleys, all the continental reliefs that we know are located in the continental crust. However, the oceanic crust, we cannot see it because it's under the seawater. Okay, these are the two types of crust. Let's move on to the next layer. Here we can see the mantle. Okay, we've seen the crust. The crust is the outer layer. Okay, beneath the crust we can find the mantle. So the mantle is between the crust and the core. The mantle is more dense than the crust, obviously, and is very thick. The thickness is 2,900 kilometers. And the main component is peridotite. Peridotite is also is a very dense rock which has a lot of olivine, which is a mineral, olivine. The mantle is solid, okay? But in your book you can read that the state of mantle is solid and semi-molten. Well, this is, I think this is, I have to explain it a little bit more. So basically the mantle is solid, but with the pressure and temperature in that conditions, the rocks that made up the mantle, they have like a plastic behavior. Se comportan como de una manera plástica, como si fuese plastilina. So it can be a flow of rocks, puede haber un flujo de rocas into the mantle. Se pueden mover y deformar como la plastilina muy lentamente. Some parts of the mantle can be molten, but also some parts of the crust can be molten. Pueden estar fundidas también, algunas partes de la corteza y algunas partes del manto. But the main state is solid, okay? So be careful with that. The inner part of the geosphere is called the core, el núcleo. The core is made basically by iron and nickel. Está compuesto por hierro y níquel. And it can be divided in two parts. We have an outer core and then we have an inner core. Tenemos un núcleo externo y un núcleo interno. The outer core is liquid. This is very important. Okay? And the composition, iron and nickel, the inner core is exactly the same in composition, but is solid. So imagine that the core is like a big ball of molten rocks with a sphere, a metallic sphere, a solid metallic sphere in the center. Es como una gran bola de roca fundida, que sería el núcleo externo, y en el interior una gran bola de acero, de metal, de hierro y níquel sólida en el interior. Why this part in the middle of the earth is liquid? Well, this is because of the relation between temperature and pressure depending on these two magnitudes, the state of the rocks can change between solid and liquid. So, well, this is the explanation. How do we know these different layers of the Earth? The core, the mantle, the crust. If we cannot see it, we cannot see these changes in composition from the surface. So a lot of people in science fiction try to imagine how can be the Earth, the inner part of the Earth, ¿no? ¿Cómo puede ser el interior de la Tierra? Julius Verne published a very famous book, Journey to the Center of the Earth, and he imagined like an inner world inside the Earth. Okay, but this is a good novel of adventure novel, but it's far from reality. Es una muy divertida aventura del viaje al interior de la Tierra, pero no es, esto no tiene nada que ver con la realidad. So, to study the interior of the Earth, we can dig a hole. Para estudiar el interior de la Tierra, podemos excavar un túnel, un pozo. But here we can see that all of these wells, todos estos pozos que podemos construir, are very shallow, son poco profundos, son muy superficiales. The record is this well dig in Russia, which is the Kola well, and it's 12 kilometers in depth. However, the crust, it has an average thickness of 35 kilometers, from 10 to 70 kilometers. So you can see that this is just a little part of the crust that we can know exactly the composition, and we can touch the rocks basically. This is an image of the well. So we need another method to know how is the interior of the Earth. Necesitamos otro método para saber cómo es el interior de la Tierra. So geologists used the movement of the seismic waves. So when an earthquake occurred, cuando se produce un terremoto, the vibration, the seismic waves can move in all directions, and their behavior changed because of the density of the rocks, the kind of material that we can find, and also the physical state, if they are solid or liquid. So studying the behavior of these waves, we can extract some conclusions on how is the composition of the Earth. So I don't going to explain this now, but basically because of these earthquakes and seismic waves, we can know how they can move inside the Earth through the materials that compose the geosphere, and we can know these differences in layers. To do that, we have a global seismographic network. We have a lot of stations that can detect the earthquakes and help us to study the inner part of the Earth. Also, it's important to know, you don't have it in your book, but it's important to know that the surface of the geosphere is like broken in different pieces. Está roto en la parte exterior de la geosfera está dividida en piezas, like the pieces of a puzzle, como las piezas de un puzzle, that we call tectonic plates, que las llamamos pues, placas tectónicas. And this is important because there's some movement between them, and that the movement between them can explain a lot of processes in geology, right? These plates are made up of continental or part of the crust and the upper part of the mantle, which is called the lithosphere. The lithosphere is rigid, okay, and it's floating on top of the asthenosphere, which is more plastic. So just to know that the tectonic plates are made by crust and the upper part of the mantle. And as you know, these tectonic plates have moved during the ages, and around 250 million years ago, all continents were together in a single continent, which is called Pangaea. And since then, the continents, the tectonic plates, have moved up to these days, where you can see a different configuration. Okay, just to remember these things. Okay, so because of the inner forces, the movement of these tectonic plates, and also the external processes like erosion, we can have some different shapes in the relief of the surface of the Earth. Debido a estas fuerzas de movimientos entre placas tectónicas y la erosión y los procesos externos, tenemos unas formas en el relieve. We can distinguish between the continental landforms and the relief features of the oceanic crust. So here we don't have the main features of the continental crust, but we know all mountain ranges. Okay, these are mountain ranges, a group or chain of mountains. Also, we can have some plains, some areas without relief, that they are called shields or cratons. These shields, escudos, are usually in the middle of the tectonic plates. Okay, in the middle of the tectonic plates, we can find shields, escudos, without relief. Okay, because most of the reliefs are related with the limits between tectonic plates. La mayor parte de los relieves de las montañas se encuentran cerca de los bordes de placa. Luego, en el interior de las placas tectónicas hay pocos relieves, and we call it shields or cratons. Good. Also, we can have canyons. Canyons are these deep valleys that were craved by the rivers. Fueron excavados por los ríos, estos valles profundos. Also, we have the continental platform or continental shelf. Okay, the continental platform or shelf is this area that belongs to the continent but is under the sea. So the continent doesn't end in the shoreline. El continente no termina en la playa, en la línea de costa. However, it continues under the seawater till the continental slope. The continental slope es el talud continental that link the continent with the ocean, right? So this is continental crust and this is oceanic crust. Good. Then we have the submarine canyons. This is another relief, cañones submarinos, that we can find in the continental slope. Okay, in the oceanic crust we can distinguish also some features like, oops, I jumped. Okay. Sorry about that. Now we can see the features of the oceanic crust. Some important ones are the volcanic islands or island arcs. These are they are arcs because they have usually this shape, like a curve, right? And they are made of volcanic islands that they are close to the continent. Some good example is Japan. I don't know if we can see it here. Okay, these islands, Japan, are an island arc. Son un arco de islas volcánicas close to the continent. Good. Then we have the guyots. Guyots are volcanoes, old volcanoes that they are not active anymore, and the top of the volcano has been eroded. Se ha sido erosionado, and they stay under the sea level. Están por debajo del nivel del mar. We have also some volcanic island that they are not included in an arc. It's like they are lonely islands, ¿no? Son islas que están solas. Also, we have the mid-ocean ridge that we can see it here. La dorsal medio-oceánica. This is a limit between two tectonic plates that they are moving apart from each other. So here we can see like a big mountain change in the middle of the ocean and under the seawater, y debajo del nivel del mar. And they are like a chain of volcanoes that produce new seafloor, que producen nuevo fondo oceánico. So this is the mid-ocean ridge. Here you cannot see because the slope is very low, but it's like a mountain. Good. And the other very important relief is the Oceanic Trench, las fosas oceánicas. They are usually close to the continents, and they can be very deep as 11,000 meters, which is the Mariana Trench. Okay, so let's stop here because now we are going, the next lesson, we will see the definition of mineral, their properties, and also the rocks and the classification. So I prefer to stop it here and make shorter videos. So if you have any question, you can ask me as always by Moodle or email, and see you in the next lesson. Bye.